I probably should have done this a while ago, but I decided to finally try a vacuum test. Here are the specs on my vacuum pump. Good to 3 times 10 to the minus 1 pascals, or 0.3 pascals. Here is my scale. I coated it with aluminum tape to reflect away any infrared light that might cause heating and errors. One other quick comment about the vacuum pump is that's the manufacturer's specifications, so I don't necessarily believe that that's the level of vacuum that I'm getting in my particular setup here. But my purpose is not to pump a perfect vacuum because I don't think that's necessary. So here's a little jug. I put just a bit of water in the bottom. I'm going to test this because it's very similar to the milk jugs which I demonstrated in previous video. And then I'm going to demonstrate the plastic container and the paper tray thing as well. Again, because that's what I demonstrated in the previous video, showing it losing weight and then gaining weight back. So I begun pumping this chamber, removing the air. You'll notice that the numbers on the balance do change while it's evacuating air, but they do tend to settle down afterwards. I was really nervous about this because this thing imploded on me a few months ago and I could have lost my eyesight. So it did caused a bit of warping, but I managed to get it back to a sort of workable condition, but I'm still nervous about it. Also, the gauge on the top there I think was damaged, so it doesn't seem to show an accurate reading anymore, but it does move under vacuum, so that's good at least. It shows that it is pumping. What you see there is a little module that measures humidity, 47% humidity it's saying, and then it measures temperature in Fahrenheit at the top corner. So the readings here did go back to 0, as you can see, and you'll start to see a slight drop there in weight. That would be minus 20 milligrams, or 0.02 grams. 39% humidity. You'll see later that this little jug actually implodes a bit, which is the opposite of buoyancy. And yet it still seems to be losing some weight, down minus 50 milligrams. And that's where it kind of hangs out. There's some limitation with this setup because I can't get the lamp very close. And also there's a lot of visible light, so it's not pure infrared. So the temperature reading there on the little digital gauge there is actually kind of irrelevant because there is no temperature in vacuum. There is only temperature probably from the plastic and the screen and the electronics that would warm up a little bit. So any temperature would just be from radiation from those materials. And it takes a while for the humidity meter to change. So that you can see there, it says saying 37%. Actually, it would be very, very low, close to 0, but So I managed to bring it down again to about minus 0.05. The second part of this video where I do the other test, there is much more of a change in weight here, or compared to this one here. So please don't miss that part. I was also a little worried about getting the lamp too close to the plastic lid. I didn't want to weaken it by overheating it, because there's about a ton of force on the lid there. That made me nervous. So we'll watch it. It should come back to 0 here shortly. (80°F) on the indicator there, which is a little bit warm. You see it's a pretty steady 0. So that weight shouldn't be coming back. And that's what appears to make this anomalous, even aside from the loss in weight. Because there wouldn't be anything in there that would go back inside that jug. There's no air in there. There's no water in any appreciable amounts. Trace amounts, but not enough to account for that change in weight. And unfortunately, our little jug suffered some implosion effects. Poor thing. That's kind of the opposite of buoyancy, though, I'd say. And now for part 2. That means 2. Congratulations, you made it. So that's a similar plastic container to what was shown in a previous video, with a cardboard egg carton paper in there, and it's a sealed container, a sealable plastic container. This paper cardboard seems to work really well for this effect, probably because it's so hygroscopic, stores a lot of moisture. So something goes terribly wrong here as I'm pulling a vacuum. This container, the lid pops off. I'm going to put this on here, like so. And now we will proceed to pump a vacuum. So I decided just to put the lid back on loosely, because the air is just going to come out anyways, and that's okay. Because the presence of air in this experiment is irrelevant, and something we are trying to remove. So it looks like our baseline is 0.1-ish. because the pulling the vacuum causes it to rise above zero. Not sure why, but there's some reason for that. It should eventually settle down to zero. So I probably should have let it do that in hindsight here. Just give it time to reset to zero on its own. But it will, you'll see what happens. My purpose here is just simply to demonstrate that there is a loss of weight and then a return of that weight. I'm not trying to make actual measurements over time or whatever. I'm just trying to point out the humidity there is reading 90%. So inside that container, it's getting quite, there's a lot of moisture in there still. So obviously I didn't pump all of the moisture out of the container and out of everything inside. And I wasn't expecting to be able to do that because that's actually very difficult to do. Now it's saying 99%. So as far as that meter goes, it's like a jungle in there. It's very moist, like 100% humidity. So considering what I said before about it going back to zero slowly, it's actually stable there at zero, even with the lamp on it. So I might even just call this a starting point, right? It's just 0.00. Takes a little while for the effect. Even if we call that a starting point 0.00, you will see a substantial change. So that's minus 0.04 grams or 40 milligrams. So just for demonstration purposes, I take it down to minus 0.1. That's kind of a benchmark, nice round number. Could have gone lower, but that just takes more time, and I just wanted to make a point here. One of those points being, I mean, there's nothing outside of that container that's going to lift it. There's no air movement. There's no buoyancy. There's no convection currents. And I say within reason to be able to account for those changes. I also take into account all of the results and observations I've made over many different kinds of experiments. And I try to look at every angle and cross-reference things too, so it's not just this, what you're looking at here, but other things I've tried, some of which I've shared recently. And there it is, folks, back to zero. And you see the humidity meter going down. Water tends to evaporate quickly in low pressure in the vacuum. That's probably why it's dropping so quickly. And our intuitive conventional reasoning would say, well, if it's evaporating, then it's going outside the container, therefore it should be losing weight. But the weight returns, goes back to zero. Unfortunately, my gauge is not working right, but it is showing that there's still mostly vacuum in there. Now I will just show the breaking of the vacuum. So it appears that nothing really got too hot. That's about room temperature. Background's about 10 degrees Celsius. Now we'll take the plastic lid off. 70 degrees Fahrenheit. Not too hot. And I just wanted to point out that there's quite a bit of condensation on that. And at the bottom of the container. Well, I hope I made a convincing case for most people. I know for some, it'll never be good enough. But I press on down the dark highway of the unknown, driven by insatiable curiosity, helping to pave the way towards a brighter future. Because I can't share all of the data that I've accumulated here on YouTube, send me an email if you're interested in seeing more, and I plan on making it available in one place, such as a website. Thank you for supporting this channel and my work, and may God bless you and have an inspirational day.